So here we are having a circuit for doing the mesh analysis to find out the mesh currents in each one of this one. As you can see, this is an AC circuit because of AC components like capacitor and inductor, and also the voltage source is sinusoidal in nature. This is basically 10 cos omega t plus 30. Not that we are interested in that, because that is hardly of any much use to us. Now it has been converted into phasor, so there is no need for us to look into that, so I will remove that. Next we are having the currents. The current generally is taken as small I1 because it is AC, so we take it as small letter, then I2, and let this be I3. You can even take capital I, it's not a big issue, but generally we follow in this manner. Now we have to write, just like we do in mesh analysis, we write the equations, the KVL equations for each and every mesh. So KVL for mesh 1. Now as you remember, we have to always, since the current is going like this, the polarity here will be plus, minus, plus, minus, plus, minus. If I am going to take the front of the component, so this is plus, so angle 10 minus angle 30 degree, 10 angle 30 degree, minus 5i1, minus 5i1, minus of minus j, so I will put plus j2i1, and now 3 is between mesh 1 and 2, so I will write plus 3 I1 minus I2 is equal to 0. Now here I have to rearrange this. Some of you may find it difficult to rearrange. Always remember that only the real values can be added together, or the imaginary values can be added together. The real and imaginary cannot be added together as an algebraic sum. So let's look at I1 components. I1 components, we are having 5 real value, 3 real value, and 2 imaginary value in I1. So I will write minus 5 plus 3, which is equal to minus 2, and in imaginary value I am having only 2j, so plus 2j I1. So as you can see, I have not added up the real and the imaginary value. I have written it as an algebraic sum. Next, I2. I2, if I have to look, there is only one I2 here, so it is minus 3I2. And this one, I have to take it to the other side. When I take it to the other side, remember, I have to either write it as minus or minus 1 into 10 angle 30 degrees. Please remember, you should not write it as minus 10 angle 30 degree, because it will be wrong in calculator. You can either write it as 10 angle 30 degree, so let me write it here. So either you can write it as minus 1 into 10 angle 30 degree, or you can just write it as 10 angle, and with this 30 degree you add 180 degree, so it will become 210 degree. So either you write 10 angle 210 degree, or you write minus 1 into 10 angle 30 degree. Whatever be the case, we can decide based on it. Let me have a look here once again. I think I have made a small mistake here. I should have taken front of this one, so I will again, this is going to be negative, this is going to be negative, so this is going to be positive, and this is going to be not minus 5 plus 3 but minus 5 minus 3, which will come out to be minus 8. Sorry for the mistake. So it is minus 8 plus 2j and 3i2 and 10 angle 30 into minus 1. So this is my first equation from the first KVL. Next I have to take the second equation from the second mesh. From the second mesh I will get KVL for mesh 2. So KVL for mesh 2, here we are having, there is no voltage source, so I will directly start. Now from here, as you can see that from the direction of current, this will be positive, this will be negative, this will be positive, this will be negative, this will be positive, this will be negative. Always current wherever it enters it is positive, wherever it leaves it is negative potential. So going by that, I can write the KVL equation now as, if I'm going to take, let's say, front of this one, so it is minus, or even I can take backside, there is no issue. Let's take for a change backside. So 3 I2 minus I1 plus, so I'm taking backside here, so backside, this one also I will take the backside of the component, so plus j5 I2 plus j5 I2, I should write it in small, so I2, and then here again we are having backside which is plus, so plus 5 I2 minus I3 is equal to 0. If I'm going for rearranging it, I can see from I1 we are having minus 3 I1. For I2 I am having an imaginary component and two real values, so 3 plus 5, I will write plus 8 plus j5 I2, and then we are having, for the case of I3 only this one is there, so minus 5 I3 is equal to 0, and that completes the second equation which I have got from the second mesh. So I will write this equation as equation number 2. Then we are having the third KVL written for mesh 3. As you can see here, mesh 3 is again having no voltage source. According to the passage of current, I will write this as plus minus plus minus plus minus. Here again I'm going to take the front, so I'm going to take minus 5 I3 minus I2, then minus 2 I3, then minus of minus j2, so it is plus j2 I3 is equal to 0, from which I can write 5 I2, then I3 I am having minus 5 minus 2, which should be minus 7, and this is plus, so plus 2j I3, so this is plus of minus 7 plus 2j I3 is equal to 0. So this is going to be my third equation. This is going to be my third equation. Now based on this, I can basically solve the simultaneous equation to get the answer, but as we all know, for imaginary or complex values, it is not possible to carry out the equation solution of simultaneous equation with the help of calculator. We have to do it with the help of matrices. In matrix form, we can write this one as matrix, so it is minus 8 plus 2j for I1, 3 for I2, 0 for I3. Similarly, for the second equation, it is going to be minus 3 for I1, 8 plus j5 for I2, and minus 5 for I3. Similarly, from the third equation, there is 0 for I1, 5 for I2, and minus 7 plus 2j for I3. With that, I will multiply I1, I2, I3, and I will get the answer based on this. For this one, it is, I can straight away write minus 1 into, but okay, let me write it like this: minus 1 into 10 10 angle 30 degrees, and here we are having 0. Similarly here also we are having 0. Now delta, we have to remember delta matrix is the matrix that we are talking about, this one. So I will write the determinant of minus 8 plus 2j plus 2j 3 0 minus 3 8 plus j5 minus 5, and then 0 5 minus 7 plus 2j. This is the determinant value we can find using calculator. We can find out what is the determinant value of this, and that we have to write it in terms of, for the case of delta. Now once we have found out delta, we can find out the value of I1 by simply writing delta 1 by delta. Delta is what we have just now seen here. Delta 1 is what? What is delta 1? Delta 1 is basically when you replace, see, when you multiply this one, basically it multiplies like this. This is multiplied with I1, this is I2, and this is I3. So this is the row of I1, this is the row, not row, column of I1, this is the column of I2, and this is the column of I3. For finding I1, when I say delta 1 divided by delta, delta is this one, whereas delta 1 is given by replacing I1 with this particular column. So I will have the determinant of minus 1 into 10 angle 30 degrees 0 0 replacing this I1 column, and then I2 column I will write as such it is. So 3 8 plus j5, and this is 5. The last column is 0 minus 5 minus 7 plus 2j, and divided by delta. Delta we have already found out here. If you would go to find out the answer will come out to be 1.43 angle 38.7 degrees. Similarly, I can find out I2. I2 will be found out by delta 2 by delta. Now what is delta 2? Delta 2 is obtained by replacing the I2, the second column, with this column. So I will get minus 8 plus 2j minus 3 0. Here I have replaced it and got minus 1 into 10 angle 30 degrees 0 0, and here again the last minus 0 minus 5 minus 7 plus 2j, the determinant of that divided by delta, and I will get the answer as 0.693 angle minus 2.2 degrees. The same thing I can find for I3, and I will just write the value of I3. For I3 you have to replace the third column with this column, and you have to find out delta 3 divided by delta. The value of I3 will come out, let me write it here, I3, just try it, you will get the I3 answer as 0.476 angle 13.8 degrees.